All right, arithmetic sequences and series. Give yourself the same care and attention that you give others and watch yourself bloom. But for real, though, like if you don't care for yourself, then you're going to struggle. I go through stages where it's like I'm caring so much for my students or for my team or for my brothers or my whoever it is, my dog. And it's like I stopped caring about myself. And then next thing you know, I'm having mental breakdowns, like you gotta, and that's when it's like, okay, Lexi, Miss Kagan, pull yourself together, right? You guys do that too. I mean, I watch you guys. I know that you're all going through stuff. Like, take care of yourself, okay? Arithmetic sequence. So what does arithmetic mean? It means adding. So arithmetic means that you're adding numbers together, okay? Don't add the way that this girl did because that is wrong, but it means that you're adding together, okay? So a sequence in which the difference between any two terms is constant. That means you're either adding or subtracting between two terms. So there's a common difference, and it's a numerical difference between any two terms. And this is always represented by the variable d. So if we want to determine whether the sequence is arithmetic, and then if yes, identify the common difference and give the next three terms. So that means we need to see, are we adding the same thing every time? So like for this one, 5 plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17. Yes, we are adding 3 each time, which means that my common difference is 3. So if I do 17 plus 3, I get 20, plus 3 is 23, plus 3 is 26. Okay, what if I have 1, 2, 3, 5, 8? Well, 1 plus 1 is 2, plus 1 is 3, but then I add 2, and then I add 3. So this one is no, this is not an arithmetic sequence. I am not adding the same thing every single time. This one, so if I go from 23 to 16 to 9 to 2 to negative 5. Well, 23 minus 7 is 16. 16 minus 9 is, or minus 7 is 9. 9 minus 7 is 3, or 2. 2 minus 7 is negative 5. Yes, you're subtracting 7 each time. So there's a common difference. So in this case, D is negative 7. If I do negative 5 minus 7, I get negative 12. Minus 7 is negative 19. Minus 7 is negative 26. Okay, so there's a formula to find the nth term. So the nth term of any arithmetic sequence can be found using this formula. So a sub n equals d, which is the common difference, times n, which is the number of terms that you're trying to find, minus 1, plus a sub 1. So a sub 1 is the first term, and d is the common difference. And n is the term that you're trying to find, or the term number, okay? So if I am given this sequence here, and I want to write a rule, and then I want to find the indicated term. So first I need to figure out what is d. So if I go from negative 5 to negative 1, I'm adding 4. Negative 1 to 3, I'm adding 4. 3 to 7, I'm adding 4. So that means my common difference is 4, and my first term is negative 5. So let's first write a rule for this. So I'm going to do a sub n equals d, which is 4, times n minus 1, and then plus a sub 1, which is negative 5. So I'm just going to do minus 5. If I distribute that 4 in, I get 4n minus 4 minus 5, which is 4n minus 9. So that is my rule for the sequence. Now, if I want to find the 24th term, that's going to be 4 times 24 minus 9, which is 87. Okay. Let's do this one. So if I go from 20 to 11 to 2 to negative 8 to negative 16, well, I am subtracting 9 each time. Except for I think I did this wrong. I think this needs to be, let me think, what's going on? Sorry. 2 minus 9. Yeah, this is wrong. This should have been a negative 7. Sorry. Yeah, because a negative 7 minus 9. It's negative 16. My bad. So that should have been a negative 7. So if I want to find the nth term, so I'm going to write a formula. So a sub n equals d, which is negative 9, times n minus 1 plus 20, which equals negative 9n plus 9 plus 20, which is negative 9n plus 29. Okay, so that is my rule. And then I want to find the 15th term, so I'm going to plug 15 wherever there's an n. So a sub 15 equals negative 9 times 15 plus 29, which I'm going to use a calculator because big brain, negative 106. Cool. Blah, blah, blah. Perfect. That should have been a 7, not an 8. Okay. All right, let's do this one. So if you're given terms as part of the arithmetic sequence, we want to write a rule and find a sub 12. So first, I need to figure out what our common difference is. I'm given 2 terms here. So I'm going to use my last term. I'm going to write this out because I think it'll make more sense. I'm going to use my last term here in this formula up here. So I'm going to say that n equals 3. Okay, so I'm going to have a sub 3 equals d times n minus 1. Wait, except for I know what n was, right? N is 3. 3 minus 1 plus a sub 1. Which now I also know what a sub 1 is and a sub 3 is. So I'm going to have negative 7 equals d times 2. I could have wrote that as 2d. Plus 3. So that's negative 7 equals 2d plus 3. If I subtract the 3 over, I get negative 10 equals 2d, which means d equals negative 5. Okay, so now I could write a rule for this. So then I have a sub n equals our d value, which is negative 5, times n minus 1, plus the first term, which is 3. So this is going to be a sub n equals negative 5n plus 5 plus 3, which is a sub n equals negative 5n plus 8. But I want to find the 12th term, so a sub 12 equals negative 5 times 12 plus 8, which is negative 60 plus 8, so that's negative 52. Cool? Here, I'm going to type through this, blah, blah, blah. There you go. Let's do one more. So if I'm given a sub 1 equals negative 17 and a sub 24 equals 6, well, I'm going to do a sub 24 equals d times 24 minus 1 minus 17 minus a sub 1. Okay, so a sub 24 is 6, because this, let me back up for a second. This would have been our a sub 1, which we knew was negative 17. Okay, and then a sub 24 is 6. So 6 equals 24d minus 17. Add the 17 over, you get 24, or 23 equals 23d. Divide by 23, so you get d equals 1. Write the rule, so a sub n equals 1 times n minus 1 minus 17. So it's n minus 1 minus 17, which is n minus 18. So that means that a sub 12 is 12 minus 18, which is negative 6. Okay? All right. So that's the sequence. Let's go into series. Remember, series means sum. So when we're finding the sum of the arithmetic series, this is the formula we can use. So we have S sub n equals n times a sub 1 plus a sub n over 2, where n is the number of terms, a sub 1 is the first term, and a sub n is the last term. So if I'm given this right here, so 2, 4, 6, 8, blah, 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 and I want to find S sub 10. Well, I know that n is 10 because they told us. A sub 1 is 2. So let's first figure out what the 10th term is, and we can use our formula up here. Or you could also just keep adding 2 and figure out what the 10th term is. This one's not too hard. But so if I do a sub 10, no, that's 2, because that's our common difference, times 10 minus 1 plus 2, which is 2 times 9 plus 2, which is 20. I'm going to plug that into our formula. So that's 10 times... so this is n. This is our first term. This is our 10th term over 2. So that's going to be 10 times 22 over 2, which is 10 times 11, which is 110. Okay, let's do this one. So I have negative 6, negative 19, negative 32. So n is 8, and our... first term is negative 6. Now I need to figure out how am I getting from here to here and here to here. Well, I'm subtracting 13. Okay, so that means my common difference is negative 13. So negative 13 times 8 minus 1 minus 6, which is going to be negative 13 times 7 minus 6, which is negative 97. Plug it into our formula. So S sub n, so S sub 10 equals, or I don't know why I put 10 right here. This should be 8. My bad. That should be 8. All the mistakes. Equals 8 times negative 6 plus negative 97 over 2, which is negative 103 over 2 times 8, which is negative 412. Okay, just a couple more. So if I'm given a summation now, remember that means our first term we're going to plug in 1, last term we're going to plug in 12. So the number of terms here, now let's think about this for a second. If I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is 1, 2, 3, oh gosh, goodness. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is easy because we start at 1. That means there are 12 terms. You're going to see why I wrote this out in just a second though, okay? So that means the number of terms here is 12. To find the first term, I'm going to plug in the bottom number. So 6 times 1 minus 4 is 2. To find the last term, I'm going to plug the top number. So 6 times 12 minus 4 is 68. And then use my formula. So S sub 12 equals 12 times 2 plus 68 over 2, which is 12 times 70 over 2, which is 12 times 35, which is 420. But let's do this one. So this one, we're going from m equals 8 to 17 of that. So if I'm going from 8 to 17, so 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms there. But what happens if I was just to do 17 minus 8? You actually get 9, right? That's because we're not including 8. You have to include 8. So if you are going to just subtract those, make sure you add 1 back into it because there's actually 10 terms there. Okay, so that means n equals 10 in this case. If I want to find the first term, I'm actually going to plug in 8 because that's the bottom number there. So I have 2 times negative 2 times 8 plus 3 is negative 13. If I want to find the 10th term, I'm going to plug in 17 because that's the top number here. So negative 2 times 17 plus 3 is negative 31. So I have 10 times negative 13 plus negative 31 over 2, which is negative 44 over 2, which is 10 times negative 22, which is negative 220. Cool? Okay, bye.